Welcome back to Professional Java Development and Test Automation Skills. I'm John Ferguson Smart, and today we'll be learning about how to make your tests more expressive and more informative using Hamcrest Matchers. In this module, we'll be looking at why it is so important to make your test readable and expressive, and how Hamcrest can help. In this module, we'll be looking at why it is so important to make your test readable and expressive, and how an open source library called Hamcrest that is actually bundled with JUnit can help. We'll be looking at and experimenting with the different ways that you can use Hamcrest in your tests. But before we look at Hamcrest, let's consider an important question. Why do we write tests? The reason we write unit, integration, or acceptance tests is not simply to check the application works. This is just one aspect of what tests do. In fact, and more importantly, we write tests to ensure that the system behaves the way we expect it to behave. In other words, our tests are a form of documentation. In behavior-driven development, we talk about writing executable specifications because the tests are a way of expressing the specifications for the application in a form that can be executed and in a form that can confirm in a clear and unambiguous way that the application behaves correctly. When we write tests for new code using test-driven development, for example, we use the tests to design our APIs. The tests, in fact, help illustrate what we'd like our code to look like, and it goes a great way helping us design clean and reusable APIs. And when we write tests that act as executable specifications, they do check that the application behaves correctly. So they do act as a safety net and help prevent bugs slipping into the code when we make changes. But more importantly, since they document what the system should do and how it should work, it makes it much easier to figure out what went wrong when the test does fail. So what turns an ordinary unit test into a high-quality executable specification? A good test is focused. It checks only one thing, preferably a clean business rule or a piece of business logic. Tests that check many different things are harder to understand and harder to maintain, and also harder to troubleshoot when they break. A good test is clear and easy to understand. It's structured in terms of inputs and clean expected outputs. Inputs and outcomes, very simple. It should be immediately obvious what the test is trying to demonstrate. A good test also focuses on what the application should do in business terms, not how it should do it in technical terms. Good tests reason in terms of the inputs and the expected outcomes in business terms, not in terms of implementation detail. This makes the test much more robust and less dependent on specific implementation. A good test is typically organized into three main parts, sometimes known as arrange, act, and assert, or in behavior-driven development terms, as given, when, and then. In the arrange section, you get the system into the initial state that you need and prepare any test data that you're going to need to run the test. In the act section, you perform the action that you're trying to demonstrate. And in the assert section, you express the outcomes that you're expecting. Here's a real example. This test demonstrates that when you calculate the total price including sales tax, then a 20% sales tax should be incorporated into the price. And we can see here, in the first section, we have a given. Given the net price is 100, so we're preparing the data. The second section is the action under test, where we calculate the total price. And finally, we have the assert, where we verify the outcome. In the rest of this module, we're going to be focusing on this last section and learning how we can use a library called Hamcrest to make this assert section much more expressive and much more powerful. This is a classic example of a JUnit assertion like the ones we saw in the previous tutorial. If you read this aloud, it would sound something like assert equals 120 total price, which doesn't exactly read smoothly. We're also basically saying that 120 is equal to total price and not that the total price is equal to 120, which would be much more natural. This actually comes from a long and now redundant programming tradition dating back to the days of C++. and it seriously hinders readability. But it's one which we're forced to use if we use the classic JUnit asserts. When we use something like Hamcrest, on the other hand, we can write something like this. Don't worry about the exact syntax just yet, but take a look at how this second expression reads. Assert that the total price is equal to 120. It just rolls off the tongue. It's a lot more readable, and because it's a lot more readable, you can actually focus on not on deciphering the syntax, but on understanding the business logic that you're trying to express. The syntax might seem a little unusual at first, so let's break it down. The assert that method is a static method from the org JUnit assert class. You can also get it from the Hamcrest Matchers assert class. The assert that method takes two arguments: the value you are comparing and a matcher instance. We usually get the matcher instance from a static method, such as the ones provided by Hamcrest's core matchers class, as you can see here. Let's look at this with some real code. The first thing we're going to do is to check out the tutorial 2 starting point. So go onto the command line in your vet clinic project, and we're going to do a git fetch if you've not already done so. Now we're going to check out tutorial 2 start. Now open up your IDE and have a look at the code that's there. The first thing we do is add Hamcrest to our dependencies. JUnit does come with a subset of the Hamcrest libraries, but we want the full set of matches. So we're going to add Hamcrest all here, and we've got the latest version, version 1.3. In this branch, you'll find a new class called When Calculating Total Prices. This class is designed to illustrate how to calculate the total cost of a consultation, including sales tax. And here we have the classic JUnit assert. Assert equals 120 total price. If we want to do this with Hamcrest, we write something like assert that total price equal to 120. Now these will come from static imports. We're going to get assert that from the assert class in JUnit, and we're going to get equals to from the core matches. Now we're going to remove this, and we can run this again. And we can see it has the same result. One of the first things you notice about Hamcrest is the large number of options that you have as far as matches go. Here we have equal to, but there are a lot more. In JUnit, you pretty much just have equals and assert true, assert false. But with Hamcrest, we can also do things like greater than, less than, contains. We have a huge range of options, and we can even write our own. For example, if we didn't want to commit ourselves to a 20% sales tax, we just wanted to say we want to make sure the total price is greater than the net price, we could do something like this. We could just say greater than, and you can see that IntelliJ is helping me and saying, okay, you can have greater than or equal to. So we're going to say greater than 100. And that would work in exactly the same way. The other great thing about Hamcrest is the clarity of the error messages that occur when something goes wrong. Suppose we said we want it to make sure it's greater than 150. Now this is obviously going to fail, but the interesting thing is what we see in the error message. So whereas a JUnit error would merely have said assert false or something along those lines, here we say expected a value greater than 150, but in fact 120 was less than 150. So it tells us 120, the value it got for the price, was less than what it was expecting, greater than something that was greater than 150. So this error reporting makes it a lot easier to troubleshoot your failing tests without having to rerun the test or put debuggers. It makes it much, much easier and much quicker to figure out what actually went wrong. Hamcrest also has a lot of matches that work with strings. Let's go back to when we create a new dog and create a new test that checks that the toString method returns a nice readable value. I'm going to call my test, a dog should be printed in a readable form. I'm going to create the same dog as I've created here. So I'm going to create Fido the Black Labrador. And what I want to check is that initially I'm going to say assert that Fido toString. Now I'm going to introduce something a little bit different here, is equal to Fido the Black Labrador. Now I'm going to do the static imports. IntelliJ will help me. Most of our matches come from the matches class. So matches, some of them are also in core matches. Most of them will be in matches. Now when I run this, it should fail because we haven't written the code to actually make it pass. And we're saying we got an assertion error. We were expecting Fido the Black Labrador, but it was the default object instance name. Now I'm going to implement this method and make it pass. So I'm going to go into the dog class at this stage. I'm going to add it to string. And I'm going to write my own. So rather than using the default one, I'm going to say name plus the very simple one. And I'm actually, what I want to do is make this lowercase so that it will read a little bit more cleanly. Now let's see if that passes. I'm going to go back to my test class. I'm going to run the test again. And that passes. But what if we want to make the test a little bit more flexible? I'm going to add some more string asserts to show you what we can do. We're going to say assert that Fido toString. And rather than saying is equal to, now is just a wrapper matcher. It's just syntactic sugar to make the method read a little more cleanly. Suppose we wanted to check that Fido was at the start of the string. So we could say, rather than saying is equal to, we could just say starts with Fido. To see if that works. So I'm going to run it again, and effectively that works. What if we want to say it should contain the breed of the dog? So we want it to contain Labrador. Or we want it to end with Labrador. We could do Fido toString ends with Labrador. Actually, Labrador. Labrador. And now, what if we want to check that the word black appears in there? We can do something like assert that Fido toString contains black. We've actually made a little mistake here. And what if we want to check that it contains the word black? We can say assert that Fido toString contains string black. Again, when we run that, that will pass. So here you can see we can match directly using equal to, but we also match partially. Start with, end with, contain string. We can also say equal to ignoring case. we could say equal to ignoring case, and in that case it would work if we checked with or without capitals. Let's run that to demonstrate, and that works as well. So you can see with the strings we do get quite a lot of options as well. Hamcrest also has the ability to do assertions on collections. Let's imagine that rather than having just one colour, animals can have multiple colours. So I'm going to write a test that says a dog can have several colours. And what I'd like is to be able to create a dog like Fido, but rather than just having one colour, I want him to be able to have several colours. So he can be a black and white Labrador. Now at the moment we haven't got the ability to do that, so we're going to have to add the capability here when we add a colour into the builder. So rather than having one colour, we're going to have several colours. And we're going to create a new dog, not with a single colour, but with a list of colours. So I'm going to pass in a list of colours into the constructor of the dog. And here we're going to have a list of strings. So rather than just a single string, we'll have a list of strings. And similarly, when we say get color, it will return a copy of the list of colors. So now let's go back to our test and do some checks. So I want to say assert that Fido get color, let's rename that to get colors. Now I want to say assert that Fido get color, and we want to say it contains black. And we can see it's saying we expected an iterable containing exactly black, but it couldn't find white. So to make it work, we would have to say contains black and white. So I'm going to run that again, and that passes. So you can see the contains matcher does an exact match on the collection that we return. But we can also do something like this. Assert that Fido get color has item black. And if we run this, then it will work, because has item means that black is one of the items in the list of colors, but it's not necessarily the only item. Now we can also do negations on this. Suppose we wanted to say not has item red. We can check that Fido's colors do not include red. So we can go quite a long way expressing domain logic and business rules in very simple terms by manipulating collections in this way. In this module, you've learnt about the importance of making tests expressive, and in particular making the outcomes of your test expressive. You learnt how Hamcrest lets you write expressions and assertions at the end of your tests that are much more readable, much more expressive, and much easier to maintain because they capture the intent of your tests much better than simple JUnit assertions. This is John Smart signing out until next time.